Hello fellas, I'm just going to go over the cart hanging mass problem to clear up any difficulties or add to your understanding. And so you can see here, as we saw in class, that we have two masses. Mass 1 is a hanging mass that will, under force of gravity, exert a pulling force along a string or wire and pull mass 2 horizontally. So mass 1 is going to move vertically or in the y direction. Mass 2 is going to move horizontally or in the x direction. So using the replay of OneNote, see how this goes. I'll add some details. First of all, the force of friction in the wheels of the cart and in the pulley are approximated as being very small or insignificant, so I'm calling them 0. So this is a frictionless system. As I mentioned, without mass 1, mass 2 wouldn't be moving. So it's mass 1 that is hanging under the influence of gravity. It's the weight of mass 1 that causes this system to move. And it's no stretch to realize that those two blocks will move in tandem or together, and that in this system they will accelerate the same way. So let's add some of these details and others. So the weight is force of gravity, which is the mass of 1 times the acceleration due to gravity. We'll use 9.81 in this. This was an actual lab exercise, and so we want to use an exact value for the acceleration due to gravity. In problems, we usually use 10, but here we're going to use 9.81. And so that is the force of gravity on 1. That hanging mass isn't falling as it would if it was not connected to the mass 2, so it's slowed down. So there must be an upwards force, and that comes from the tension in the string or the wire. And that is a force acting upwards, force of tension of 2 on 1. And likewise, as we've said, mass 2 wouldn't be moving if it wasn't being pulled by the tension force in that wire or string. And so that is the other member of what is a force pair, force 1 on 2. Force of gravity acting on 2 is acting vertically or in the y direction. That has no effect on the motion, really. And there is a normal force if we wanted to include all the forces acting on 2. So there is the force pair, just filling in. Question 2. These will accelerate the same way, and we can describe the acceleration as horizontal and vertical, or in the x direction and the y direction. They're all correct. So I've used x and y. They're the same. The acceleration of both blocks is the same. Now we're going to do, as in many problems, and write an expression for the net force on the system. And the system is both blocks together. So S will be blocks 1 and block 2. So the net force on the system is, as ever, the sum of all the forces. So we've got the weight of 1, really what's causing this all to happen. That's force of gravity on 1. And the members of the force pair, and considering the system, they will cancel. And then using Newton's second law, we know that the mass of the system times the acceleration of the system also equals the net force on the system, where the acceleration of the system is the acceleration of x and the acceleration of y. I'll stop here and then continue on.